All of NMAP's port scanning options are enabled using the -s option and an uppercase letter argument designating the type of scan desired. We'll be discussing 7 of these scan types. The first one, capital U, specifies that a UDP scan should be performed. The rest of them all specify different types of TCP scans. We'll discuss each of these options in turn. Once a scan type is specified, NMAP sends appropriately constructed probes to the target and listens for the replies. One of 4 results might occur. A reply packet might be received from the application running on the target port, from which we can conclude that the target port is open. We could receive an ICMP port unreachable error or reset packet, which indicates that the port is closed. We could receive an ICMP error message from an intervening router, which indicates that communication with the system or port is prohibited or filtered. Or lastly, we could hear nothing back. For each of these scan types, we'll investigate each of these 4 results. Let's start with UDP port scanning. UDP port scanning is enabled using the -s capital U option as shown in this command. Open UDP ports are only detected when the associated application provides a reply. Probes sent to UDP ports that commonly provide replies, such as DNS on port 53 or SNMP on port 161, contain a payload designed to elicit a response from the target application. Probes to other UDP ports have an empty payload. Closed ports are easily detected when an ICMP port unreachable response is received. These ICMP error messages are sourced from the target system. ICMP error messages from an intervening router or firewall indicate that we are prohibited from reaching the destination system. These errors are not sourced from the target and are classified by NMAP as filtered. Some of the ICMP errors that NMAP might receive are listed here. Again, these errors are generated from an intervening router and not by the target, so the receipt of one of these messages doesn't tell us anything definite about the target other than we're not allowed to communicate with it in one way or another. Lastly, a probe might not ever receive a reply. NMAP will time out waiting for a response and resend the probe, but eventually it will give up. There are at least 2 explanations for not receiving a response. One is that an intervening router or firewall has silently dropped the probe. The other is that it could also be an open UDP port under normal operations. Many UDP services run as listening services and accept incoming packets and never or rarely provide a response. Syslog is one example of such a service. It will happily accept incoming log entries, but never provide a reply or confirmation of receipt. Because of these 2 possibilities, if NMAP never receives a response, it can't determine if the port is open or filtered, so it reports both. These results are summarized here in this table. We'll add to it as we look at each scan type so we can compare the results of each method. Let's execute a couple commands and look at the output. In this command, I'm asking NMAP to perform a UDP scan on port 53 of 192.168.0.1. The results show that the domain service on UDP port 53 is open and accepting connections. The reason NMAP provides indicates that an application response was received to the query included with the probe. Let's take a look at another example. This command is probing the ISACAMP service on my cell phone. ISACAMP is used to exchange cryptographic keys, usually as a precursor to establishing a VPN tunnel. I'm expecting this port to be closed. Sure enough, NMAP found the port closed and reported the reason as port unreachable, indicating that an ICMP Type 3, Code 3 message was received. The rest of these options all specify types of TCP scans. Let's start our discussion with the Connect scan, which is enabled using the -s T option. With a Connect scan, NMAP attempts to perform the complete 3-way handshake. If the connection is established, NMAP terminates the connection with a reset packet. These sessions are established using the operating system's network packet construction routines and can therefore be executed by non-root users. Open ports are positively determined since a SYNAC packet is returned from the application running on that port on the target system. Closed ports are also positively determined since a reset packet is returned from the operating system on the target system. As with UDP, ICMP error messages sourced from intervening routers are classified as filtered, and if no response is received, NMAP also reports the port as filtered. Here's our updated response table. Note that with the TCP Connect scan, we received a reset packet from the application rather than an ICMP port unreachable, as with UDP. Also, notice the difference in classification for no response. With UDP, there's some ambiguity between open and filtered. That's not the case with TCP. All right, let's do another quick demo. In this command, we're requesting that NMAP perform a TCP Connect scan against port 80 and 81 on the default router for my office network. As you can see, NMAP received a SYNAC from port 80 and therefore lists the port as open. A reset packet is returned for port 81 and NMAP lists it as closed. Since NMAP is relying on the operating system's network packet construction routines for Connect scans, it also relies on them for errors. In this case, NMAP gives the reason as reported by the operating system, which is connection refused. The S argument defines half-open scanning and is enabled using the -s option. The capital S argument specifies a TCP half-open scan. For each port scanned, NMAP begins a normal three-way handshake, but after the initial SYNAC response, the connection is terminated with a reset packet. Packets for these sessions are built using NMAP's internal packet construction routines and therefore require root privileges. This is the default scan type if performed as root, since it is the fastest and uses minimal resources on both the scanning system and the target. If you attempt to execute the scan as a non-root user, NMAP barks at you and aborts. The results of a half-open scan are identical to a Connect scan. Again, open ports are positively determined since a SYNAC packet is returned from the application. Closed ports are also positively determined since a reset packet is returned from the operating system on the target. ICMP error messages are interpreted as filtered, and if no response is received, the port is also classified as filtered. The results from the half-open scan are identical to the Connect scan. Between the two options, it's best to perform the half-open scan unless you're scanning as a non-root user. All right, let's look at the results of a half-open scan. In this example, we're duplicating the command from the Connect scan type and have only changed it to perform half-open scans using the capital S argument. The only difference in the output is the reason supplied for port 81, which is closed. Since NMAP performed the scan using its own internal packet construction routines, it is able to provide an exact reason for the closed classification, which in this case is due to a reset packet. These three scan types are very similar, so let's discuss them together. TCP null, FIN, and XMA scans are enabled with the capital N, capital F, and capital X options as shown here. These scans use specific flag settings in the TCP header when constructing the probes. Here's the TCP header again. The null scan sends a packet with no flag set. The FIN scan sets the finish flag, and the XMA sets the urgent, push, and finish flags, lighting the packet up like a Christmas tree, hence the name. Other flag combinations that produce identical responses are possible, but the important point is that the SYN, ACK, and reset flags must not be set. The reason is that during a normal TCP conversation, there should never be a packet that doesn't have at least one of the SYN, ACK, or reset flags set. It just shouldn't happen. The RFC describing TCP communications states that if a system receives a packet without the SYN, ACK, or reset bits set, it should drop the packet. What this means for interpreting our scan results is that using any of these three options, N, F, or X, you'll never be able to positively determine if a port is open, since the target should drop the packet and you'll never get a response. This result is the same ambiguity with UDP scanning. No response could mean either that the port is open or filtered, but we can't determine which. In both cases, NMAP reports the port as open/filtered. Closed ports respond with a reset packet. If an ICMP error message is returned from an intervening router, NMAP classifies the port as filtered. Here's our updated table. Because the N, F, and X scans will never identify an open port, they are of limited usefulness. A few situations where they might be of use are when working through packet filtering firewalls and attempting to avoid IDS detection. Even so, they should be used as a last resort. Let's do a quick demo of a fin scan. Here we're scanning the same ports on the default router for my network using a fin scan. The results show that a response was never received to our probes on port 80 since the proper handling of a fin packet that's not part of an ongoing conversation is to drop it. NMAP can't distinguish between open and filtered ports, so it reports both. A reset packet was received for port 81, clearly indicating that it's closed. Finally, let's talk about ACK scanning. TCP acknowledgement scanning is enabled using the -(s) option. Like with the ACK host enumeration technique presented earlier, the ACK port scanning option sends an acknowledgement to non-existent data. When scanning both open and closed ports, the target system will always return a reset packet, so NMAP labels them as unfiltered, meaning that they are reachable by the ACK packet, but whether they are open or closed is undetermined. Again, if an ICMP error message is returned from an intervening router, NMAP classifies the port as filtered. And as with other scan types, non-responsive probes are followed up with repeat queries, and ports that don't respond are labeled as filtered. The ACK scan is great for mapping out firewall rules. If we can reach the target system to either open or closed ports, we know that a firewall allows that traffic. If we can't reach the port, it is assumed that a firewall rule is blocking or filtering the traffic. We'll come back to this subject in our discussion of firewall and IDS evasion techniques. Let's look at some output from an ACK scan. Here we're scanning ports 20 through 25, and port 80 and 443 on 192.171.229.13. Since an ACK scan receives identical responses from both open and closed ports, we can't tell the difference. These ports are reported in the output as unfiltered, and the reason given is that NMAP received a reset packet. Other ports are listed as filtered. These results don't tell us as much information as we'd like to get back about the target, but they do reveal the configuration of any filtering devices between us and the target. In this case, we can surmise that a firewall is blocking access to ports 22, 25, and 80. To complete our discussion of port scanning options, let's reiterate the -(SN) option. As we've already seen, there are times when we want to disable the port scanning phase entirely, which this option does for us. Port scanning is NMAP's core process and allows the identification of services running on a target system. The two most frequently used options are the U for UDP port scanning and S for half-open scanning, which should be the go-to port scanning types in most situations. The identification of open ports helps the security tester to identify the purpose of a system and inventory the applications running on the target. In the next module, we're going to continue talking about the port scanning phase and introduce several options that allow us to control the all-important balance between scanning speed and accuracy.